Hello everyone and welcome back. My name is CA Gaurav Chopra and we are doing integration. So let's see who all are live with us now. Pooja Patil, Ishan, Ankit Mishra, Shivangi, Sahil Khan, Diksha Agarwal and Bhumika. Great. Good afternoon everyone guys. So in the previous session we had covered all the basics of integration. We have done two kinds of different formulas. One were the basic set of formulas and then some standard formulas, some standard result based on integration. So some more are live now. Lakshita is there, Madiha Khan, Bhargavi, Chaitanya, Gaiza, Kushdeep, Gunjan Devi, Rohini, and Soumya. Great. Good afternoon, everyone. Good to see you here, guys. Then Gautam is also there. Patindya, Manvi, Asha, Isha Pandit, Mohammed Hassan. Great. So welcome everyone. Now continuing the chapter integration. So in the previous session, we have learned some of the formulas. I hope you have remembered all the formulas and you have done all the revision till here. Now today we are going to learn some more topics, some more formula and some of the shortcuts which we can apply at some of the places. So let us begin with shortcut first. So let's write the shortcut. Now when this shortcut is applicable, we have to see that also. So first we can write when differentiation when differentiation of denominator when differentiation of denominator is available in numerator. When differentiation of denominator is available in numerator, then we can apply one formula. So let's see what is that formula. So the first one is integration of f dash x divided by fx dx. So we can write the formula as log of fx plus c. So when differentiation of denominator is available in numerator, then we can apply this formula. And the next one is integration of. Now in denominator this time we are having root and function is available inside the root. Function is available inside the root. In numerator we are having f dash x. So if this kind of situation is there, we can directly apply the formula to root fx. And then at last we can add constant. Okay. So these are the formulas. We can apply this. Yes, some more are live now. Rafika, Sonali, Sanjana, Jyoti, Achal, Nitil Soni, Vivek, Abhinav Kumar, Radhika, Faizan Ali, Ustad Singh, Zeba. Great. So let's do one question based on these. Integration of 2x plus 5 divided by root of x square plus 3x minus 5 and then dx. So we have to find integration of this. Now clearly we can see that which kind of shortcut is applicable. Here we can see that the second shortcut is applicable because in denominator inside root there is a function, and if we differentiate this function, that is 2x plus 3, that is available in numerator. The differentiation of denominator is available in numerator. So we can directly write our result as 2 root of x square plus 3x minus 5. And then at last we can add the constant c. That's it. Just one step and we can get the answer. All right. So this is the first thing which we have to do. Now, the second thing which we have to focus on is the partial fraction, that is the next variety. Now, this method is a bit of lengthy method, but we can try one question. So normally, very much lengthy question doesn't come into examination, especially when we are talking about the partial fraction. All right. So we are having 3x plus 2 divided by x minus 2 and then x minus 3. So whenever here the numerator is having power 1. If we talk about the variable, the numerator is having maximum power of 1. Whereas in denominator, if we multiply, the power of x will become 2. That means whenever the numerator is having less power, we cannot divide them. So it is not possible to divide them. Then we can apply the partial fraction method. So in this method, what we have to do, we can split them. How to split them? Let's understand. 3x plus 2 divided by x minus 2 and then x minus 3. Now we want to split them. Now since x minus 2 and x minus 3 are into LCM, we directly cannot split them. So we let the numerator of x minus 2 be a and let the numerator of x minus 3 be b. So we have taken the numerator as a and b. Now what we can do, we can take the LCM. So a x minus 3 plus b into x minus 2 divided by x minus 2 and then x minus 3. On left hand side, we are still having the same values. Okay. Now we can see that in denominator, we are having same values on both the sides. So we can cancel them. All right. We have cancelled them. Now we have to obtain the value of a and b. We have to obtain the value of a and b. How to obtain that? So for obtaining the value, what we can do, we can compare the value of x minus 2 with 0. We are getting x as 2 and the value of x as 3. We are getting two values of x. Now one by one we can insert the value and get a and b. So let us insert them and get the values. So 3x plus 2 is equal to a x minus 3 plus b multiplied by x minus 2. Now in this equation, we have to insert the value of x and value x as 2 and 3 one by one. So first of all, we can insert 2. So 3 multiplied by 2 plus 2. A 2 minus 3 plus b into 2 minus 2. Now from this we can see that 8 is equal to minus of a plus b into 0 is 0. So we can see that clearly value of a is equal to negative 8. So we have taken out the value of a. Similarly, we can get the value of b as well. So by inputting 3. So let us input 3. 3 multiplied by 3 plus 2 is equal to a 3 minus 3 plus b 3 minus 2. Now how much we are getting? 11 is equal to 0 plus b. So value of b becomes 11. Value of b is equal to 11. Now we can insert the value of a and b and get the desired result. So we can see that the integration is equal to minus 8. In place of 8, we have written, in place of a, we have written minus 8 and denominator was x minus 2 plus in place of b, we can write 11 and then x minus 3 dx. So till here what we had done, we had calculated the numerator by partial fraction method. Now we can easily integrate them and get the result. So minus 8 log of x minus 2 plus 11 multiply by log of x minus 3 and then plus c and then plus c. So this is the complete method of partial fraction. So whenever the numerator, the power of numerator is less as compared to denominator, then we can use this partial fraction method. So for using this, we have to split them into two parts. So we have written a and b. In case of 3, we can insert c as well. Then after that, we can take LCM and cancel out the denominator on both the sides. After that, we have input the value of x. So we are having x as 2 and 3. So one by one, we have inputted 2 and then 3 and got the result of a and b. And after that result, we have simply applied the formula and got the answer. Okay. So now this question can be done with another way as well. So let us try one question with another method. The question is this time, find out integration of dx divided by x minus 1, x minus 2. Dx upon x minus 1 and then x minus 2. This we have written. Now what we can do, we can multiply them first. So let us multiply x minus 1 and x minus 2. So x squared minus 3x plus 2. So after multiplication, we have got this. Now one thing can be done, we can make this as perfect square. We can make this denominator as perfect square. Now how to make an equation as perfect square? So we have to first of all see the coefficient of x. What is the coefficient of x? The coefficient of x is minus 3. Now in order to make this perfect square, what we have to do, we have to divide this coefficient by 2 and then make the whole square. And then make the whole square. So how much we are getting? 9 by 4. Now we can add 9 by 4 and we can subtract 9 by 4. Adding and subtracting 9 by 4 in the given equation. Now by using x square minus 3x and 9 by 4, what we can do? We can write them as dx upon x minus 3 by 2 whole square. So we have converted this into whole square. Now what is left? Let's check. We are having 2 minus 9 by 4. This is left. So let's see what happens. So dx divided by x minus 3 by 2 whole square and then minus 1 by 4. And 1 by 4 can also be written as 1 by 2 square. 1 by 2 square. Now we can apply the formula of dx divided by x square minus a square. X square minus a square, we can apply this formula. So let us apply the formula. So whenever we are applying the formula, we have to carefully see what is the value of a and what is the value of x. So as per formula, it is 1 upon 2 of a. Now what is the value of a? A is half here. So we are writing 1 upon 2 into half multiply by log of x minus a divided by x plus a. So this is complete x, then minus a divided by x plus a. Then we can cancel. 2 and 2 is getting cancelled. So what is left? So we are left with log of x minus 2 divided by x plus 1. And at last we can add the constant, that is c. So we can convert this into whole square, and after that we can apply the formula of x square minus a square. All right. But the numerator should be 1 in this case. So whenever we have to apply this whole square method, then the numerator should always be equal to 1. Now there can be one more way of solving such questions. We can even solve some of the question by using options. We can solve using options. Now, how to solve using options? If we differentiate the option, whenever option is written, if we differentiate the option, we will reach our question. We will reach our question. So we can try this. Let's say the result is log of x minus 2 upon x plus 1, and then plus c is there. Now we have taken this as y. If we try to do dy by dx, so before that we can apply the property of log m upon n, log m minus log n, and then plus c, it is equal to y. This is equal to y. Now we can apply the formula for differentiation. Log of x is 1 upon x minus, again log of x, 1 upon x plus 1, and constant becomes 0, is equal to dy by dx. Now we can take the LCM here, and here it was minus. We can make one correction. In denominator it was negative sign. Sign was negative. All right, yes. Now we can take the LCM, x minus 2 and x minus 1. So let's see what we are getting. So in numerator, we can clearly see that x will get cancelled, and we have got 1 divided by x minus 2 and x minus 1. So we have reached our question. So whenever we differentiate the option, and if we are reaching towards our given function, given question, that means that option is correct. And if that option is unable to help us to reach the function, that means that option will be wrong. So in this way, by reverse calculation, we can do the same. Okay. So whenever the numerator is 1, then what we can do, we can convert this into whole square, apply the formula of x square minus a square, and then get the result. And the second way was to solve using options. So using option, if we differentiate the option and we reach the given function, that means that option is correct. All right. Then let us try one more. Now this time the question is dx divided by 2x square minus x minus 1. Now before applying to the whole square, it becomes easy if the coefficient of x square is equal to 1. So what we can do, we can rewrite this as, if we can multiply and divide by 2, then what will happen? So it will become x square minus x by 2 minus 1. And outside we can write 1 by 2. So what we have done, multiply and divided by 2. So after multiplying and divide by 2, now the coefficient of x square is 1. Now we can do the completing square method. Now for completing square method, what we have to do, divide the coefficient by 2 and make it square. So what is the coefficient of x now? 1 by 2. Divide 1 by 2 by 2 and then make whole square. So what is the whole square? Whole square become 1 by 4. Now adding and subtracting 1 by 4. Adding and subtracting 1 by 4. So 1 by 2 integration. Now in upper step only, let's add 1 by 4 and subtract 1 by 4. So what we are getting? Dx divided by. So 1 by 4 is the square of 1 by 2. So what we can write? X minus 1 by 2 whole square. Or we can write, I think we have to make some correction here. Yes, it was 1 by 4 square. So it become 1 by 16. So here we can write 1 by 4 whole square minus 1 by 2 and then minus 1 by 4. Minus 1 by 4. So how much we are getting? 1 by 2 dx divided by x minus 1 by 4 whole square minus 3 by 4, and here also we can write 1 by 16. So how much it becomes? 1 by 16 and 1 by 2. If we take the LCM between these two, LCM will be 16 and it becomes 8 plus, we can take minus as common. It can become 8 plus 1, that is 9 by 16. This is basically 9 by 16. And 9 by 16 can be written as 3 by 4 square. So x minus 1 by 4 square minus 3 by 4 square. Now we can apply the formula of integration 1 by x square minus a square. So let us apply. 1 by 2 will remain as it is. Now what is the formula? 1 upon 2a. In place of a we can write 3 by 4, then log of x minus a divided by x plus a. Now we can solve and get the result. Now 4 will get cancelled with 2 and 2. So we are left with 1 upon 3 log of minus 1 by 4 minus 3 by 4, it becomes x minus 1 divided by x minus half. X minus half. And at last we can add the constant c. We can add the constant c. Okay. Now let's try the next one. That is, yes, this one. Dx divided by x cube plus 1. X multiplied by x cube plus 1. Now, in such cases, we can let and solve. So let us assume. So we are having integration of dx divided by x multiplied by x cube plus 1. Now what we have to do, we have to assume first. What we can assume? Let x cube is equal to t. If x cube is equal to t, differentiating both sides, we get 3x square is equal to dt by dx. Dt by dx. Now, if we see the numerator, we are having only dx. We are having only dx. So in place of dx, what we can do? We can write dt by 3x square. Or one thing can be done, we can multiply and divide the numerator, we can multiply and divide by x square. So it becomes easy. So let us do that also. Multiply and dividing by x square. So it will become x square dx upon x cube multiplied by x cube plus 1. Now in place of x cube dx, what we can write? Dt upon 3. So we can write dt upon 3. Then in place of x cube, we can write t. And what is t cube? X cube, we have already taken it as t plus 1. Then what's the next step? We can easily separate them and get the result. So it becomes 1 by 3, 1 upon t minus 1 upon t plus 1. Next step is, what is the integration? Log of t minus log of t plus 1. Now in place of t, we can again put the value and get the result. So it can be 1 by 3. Now it can also be written as log of t divided by t plus 1. So 1 by 3 log of t becomes x cube divided by x cube plus 1. And at last we can add the constant c. All right. So Bhumika has given the answer. So in such cases, we can let the things and get the result. All right. Then next one is a bit different question. Find the equation of the curve where slope at x comma y is 9x and which passes through the origin. So it passes through origin. Now, whenever we are talking about slope, slope means dy by dx. So the question is given the value of dy by dx. How much it is? 9x. Dy by dx is 9x. So now it passes through origin also. So we can write this as dy is equal to 9x dx. If we integrate both the sides, integration of dy becomes y and integration of 9x becomes 9x squared divided by 2 and then plus c. Now the question says that it passes through origin. Now whenever it passes through origin, the value of constant becomes 0. The value of constant becomes 0. So there is no need to write this c. We can remove this constant because it is passing through origin. So what will be the final result? 2y is equal to 9x square. This is the required equation. Okay. Then the next will be definite integration. Now, what is the difference between definite and indefinite? So till now, what we have done in the chapter was indefinite integral. Indefinite means there was no limit. Value of x and y can be anything. Value of variable can be anything. But now we will be talking about definite things, like there will be a certain limit from that value of x lies from 1 to 3 or 1 to 4. So such kind of limit will be there in the integration. So whenever such limit is there, then we can name it as definite integral. And since the limit is defined, that means there is no need to assume the constant. There is no need to assume the constant. So we will not add c indefinite integration. So whenever definite integral is there, no need to add constant at last. So let's read this. As x changes from a to b, the value of the integral changes from fa to fb. So fx is given, then sign of integration on one side, that is on lower side, value of lower limit is given. On upper side, there is one more value, that is upper limit. Now we have to put this value in such a way that bigger value comes first. So f of b minus smaller value. So always at bottom lower value will be taken in numerator, and then at the top higher value, bigger value will be taken. So let's try one example. So if the question is x to the power of 5 dx, where value of x lies from 0 to 2. So first step is to integrate this. Now what is the integration? X to the power of 6 divided by 6. No need of constant. Now we have to put the square bracket and write the limits. So it is 0 to 2. Now apply the upper value first, that is the bigger value. So it becomes 2 to the power 6 upon 6 minus 0 to the power of 6 by 6. So how much it comes? 64 divided by 6, or we can say 32 upon 3. So this is the final result. Okay. So let's try another one. This time limit is from 1 to 2 x square minus 5x plus 2 dx. So first step is to integrate them. So let us integrate. X square will become x cube upon 3 minus 5x square divided by 2, and then 2 will become 2x. And applying the limit from 1 to 2. So first of all, we have to put 2. So let's put 2. So 2 cube divided by 3 minus 5 into 2 square upon 2 plus 2 into 2. Now what we have to do? Minus and then put the second value, that is 1. So 1 cube upon 3 minus 5 into 1 square upon 2 plus 2 into 1. So how much we are getting? 2 cube is 8 by 3 minus 5 into 4 is 20, 20 by 2 is 10 plus 4, and minus 1 cube by 3 is 1 by 3 minus 5 by 2 and then plus 2. So how much we are getting? 8 by 3 minus 6, then minus 1 by 3 minus 5 by 2 and then plus 2. Now we can take the LCM and then solve them. So the LCM will be 6. So how much we are getting? 16 minus 36 minus 2 minus 15 and then plus 12. So how much we are getting? 16 plus 12 is 28, and from 28 we can subtract the values and get the result. So finally we are getting minus 19 upon 2. Okay. So Lakshmi says looks very easy. Avinash also says very easy. All right. So now Nikhil Soni says, can you please repeat? Okay. So whenever we are having definite integration, what we have to do? We have to apply the normal integration formula first. Now, after application of the formula, no need to add constant. Now, after that, what we have to do, where whatever is the variable, we have to put the value in that variable. So what is the upper value? It is 2. So first put 2. So first we have to put 2, then minus. After that, we have to put 1. And then minus in between. All right. Now there are some important properties for definite integrals. So let's learn these properties first. The first property is here integration of any function from a to b is equal to integration of another function with another variable t from a to b. So if we are changing the variable, in place of x we are using t, the result will be same. In place of x, if we use y, we use z, we use a, anything. So if variable is changing, then the result is not getting changed because we are having the definite limit. Since the limit is same. So the first property says it is independent of variable. It is independent of variable. We can use any variable. Second property says if there is any function whose limit is from a to b, if we want to reverse the limit, like if we want it should become from b to a and the function remains same, then what needs to be done? We have to put negative sign outside. So we can take negative side outside and interchange the values. That is, a and b can be exchanged. So for that, we have to put negative sign outside. This is property number 2. Then property number 3. Now property number 3 says we can split the values. If there is any function from a to b, now if we have requirement, we can split this into 2 parts. That is from a to c, we can calculate, and then from c to b again, we can calculate and get the result. But c should lie between a and b. C should lie between a and b. For example, if we are having any function and limit is from 1 to 5. So what we can do, we can travel from 1 to 2 and then plus from 2 to 5. So we can split them into 2 parts if required. Also, it can be 1 to 3, and after that from 3 to 5 we can do this. So we can split as per our requirement. So 1 to 3 and then 3 to 5, 1 to 2 and 2 to 5. Okay. So Manoj Pato says, I couldn't understand this property in class 11th and 12th, but now understood. That's great. All right. So we have to split this. Then the fourth one. The fourth property is required at many places. This is limit is from 0 to a. Function is there and then dx. Now this can also be written as function in place of x, we can write a minus x. This time what we have done, limit is same, but in place of x, we have written a minus x, and the result will be same. The result will be same. So whenever the limit is from 0 to a, then only we can apply this formula. So it is from 0 to a, and then the function is there. So we can write a minus x in place of x. A minus x in place of x. Then similarly, if there is any function with limit from 0 to n times of a, so we can keep this n outside and then integrate from 0 to a, and at last multiply the result by n. So both will give us the same result. Both will give same result. Then the next one, if the limit is from negative a to positive a this time, from negative to positive a, values are same but with different sign. One is negative, other is positive. Then one thing can be done, we can change the limit from 0 to 2. Write the function and at last multiply by 2. So why we have done 2? Because we are reaching from one corner to another. We are having minus a here and a on other side. In between it is 0. So we have to travel from minus a to a. We have to travel from minus a to 0 and from 0 to a. So in this manner, we can travel. All right. So this is first part. This is second part. So that is why we have to multiply it by 2. So 2 times of integration 0 to 2 fx dx. So 0 to a we can write here. 0 to a. So whenever we have to travel from negative to positive, we can write in this manner. All right. Then let's try some property-based question. So let's try this example. Now this example is a tricky one. What we have to do, this is the given question, x square dx divided by x square plus 2 minus x whole square. This is given. Limit is from 0 to 2. Now, by seeing this question, it becomes very complex. But one thing we can do, we can see which property is applicable here. Here, x is written, and here it is 2 minus x. And 2 is available in limit also, because limit is from 0 to 2. So whenever the limit is from 0 to a certain value, we can apply a minus x formula. So just by using that formula, we can replace x with 2 minus x. We can replace x with 2 minus x. So let's do the replacement. Limit is same, 0 to 2. In place of x, we are writing 2 minus x square dx divided by 2 minus x square and then plus x square. This we have done. So this becomes property number second. So equation number second. So if we denote the first one by I and second also by I, And we are having the first equation and the second equation. Now here is one simple trick. We can add both the equation and get the result. So I plus I, it becomes 2 times of I is equal to now let's add them, x square dx divided by x square plus 2 minus x whole square plus 2 minus x whole square upon 2 minus x square plus x square. We have done the simple addition. Now, if we add them and see what is the result, some of the values will get cancelled. We can easily see that x square plus 2 minus x whole square is available in numerator and same value is available in denominator. Now, numerator and denominator both are having the same value. So since the values are same, we can cancel them and see what we are getting. So we are available with only one, that is dx. Only dx, and limit is still from 0 to 2. Limit is from 0 to 2. This is the value of 2i. So if we integrate this dx, what we get x. We get x, and after that we can apply the value, that is 0 to 2. So how much we are getting? 2 minus 0, that is 2. Now this 2 is the value of 2i. So what is the value of I? It becomes 2 upon 2, that is 1. So 1 becomes the final result. So in this manner, we can apply the property of definite integrals. All right. So here we had applied the property number 4. So whenever the limit is from 0 to any number, then always check whether this property is applicable or not. If it is applicable, just form the equations and add them. After adding them, numerator and denominator both will get cancelled and we will get the final result. Okay. Bhumika says understood, Lakshmi understood, Barkat understood. Great. Now the next one. This is also a bit of lengthy question. Evaluate x to the power of 4 dx divided by a to the power of 10 minus x to the power of 10. And question says that value of a is greater than 2. Value of a is more than 2. So in order to apply the property or some of the formula, we can try some of the things. Whenever x and a both are written in denominator, there are in most of the cases we can apply the formula of x square minus a square. So let's see which kind of formula we can apply here. So the value is x to the power of 4 divided by a to the power of 10 minus x to the power of 10 dx. Limit is from minus 2 to plus 2. So here the limit is from minus 2 to plus 2. So at some time we can apply the property of 2 times and then from 0 to 2. So we will try this at later stage, but before that we have to integrate them and simplify them. So one thing can be done. The power 10 can be written as power 5 whole square. So a to the power of 5 whole square minus x to the power of 5 whole square dx. This we have written. Now In denominator, we are having x to the power of 5 and numerator x to the power of 4. So if we take x to the power of 5 as t and then differentiating both the sides, what we get, 5 x to the power of 4 dx is equal to dt. So x to the power of 4 dx can be written as dt by 5. So this we can do. So dt by 5. Then what is left? A to the power of 5 square minus t square. Minus t square. This is available. Or now what can be done? We can apply the formula of 1 upon a square minus x square. So 1 by 5 remains as it is. Then the formula is 1 upon 2a. What is the value of a? A to the power of 5. Log of a plus x upon a minus x. So this is a plus x is t, or in place of t we can write x to the power of 5. So we have applied the formula. Now after this we can do some simplification. 1 upon 10, 1 upon 10, then a to the power of 5 log of a to the power of 5 plus x to the power of 5 upon a to the power of 5 minus x to the power of 5. And the limit is from 0 to, no, at present the limit is from minus 2 to 2. If we have to convert this from 0 into 2, then we have to multiply it with 2. So we have multiplied by 2 and changed the limit from 0 to 2. So what is the benefit of making this 0? So if we put 0 in place of x, the calculation becomes very much easy. So that is why we can apply this formula. So after application, we are getting the final result as 1 upon 5 a to the power of 5 log of a power 5 plus 32 upon a power 5 minus 32. So this becomes the final answer. Okay. So this was definite integral. Now we can try some extra questions for the practice. Lakshmi says properties are easy. Yes. So let us do some of the questions. Now one question which can be done is limit is from 1 to 2 e to the power of x 1 upon x minus 1 upon x square dx. Now which formula should be applied here first? This we had discussed in the previous session. So whenever there is one function and its differential is available just nearby, and outside the bracket there is e to the power of x, then we can apply the shortcut here and get the result. So what is the shortcut for this? We can simply write integration as e to the power of x divided by x, and then now apply the limit from 1 to 2. So if we apply 2 first, e to the power of 2 upon 2 minus e to the power of 1 upon 1. And if we want, we can take e as common. So e by 2 minus 1. So this can become the final result. Bhumika says in third rule, C could be any number or it can be between A and B. So Bhumika, in property number 3, C is any value which lies between A and B. If the value of A is, let's say, 2 and value of B is 6, then C will be any number between 2 and 6. So C can be like 3, it can be 4, 5, it can be any number, but between 2 and 6. Then Kaustubh is asking, in the previous example, in place of 2 minus x square, it becomes x square how? See, what we had discussed that in place of x, we are substituting 2 minus x. So here also, we have substituted 2 minus x in place of x. And by doing this, 2 got cancelled. 2 got cancelled and we are left with only x square. Okay, Kaustubh? Understood? So wherever we are having x, we have to do the replacement at all the places. So we have replaced x here also. 2 and 2 got cancelled and finally is x square. So I think this is clear. Now let us have some small break and after that we will do different variety of questions, some additional question and some from back so that we can have more practice on these questions. Okay, so let us take a small break of 5 minutes. Welcome back, everyone, after the break. So now let's have some extra questions, some additional questions for the practice. Now you have to answer in rapid fire manner. Come on. Let's try the first question. Try to solve each and every question as fast as possible. So the first one is integration of e to the power of log x to the power of 6 base e. So this you have to solve. E to the power of log x to the power of 6. Now, as per the property of logarithm, if we see that log with base e, if it is available in power of e, whenever this is available, e, so this thing completely will get removed. E and log will get removed, and what is left, that will be x to the power of 6. Now we can simplify and get the result. So what will be the result? X to the power of 7 upon 7 plus c. All right. So this will be the result. Then the next one, x square plus 1 divided by x dx. Now we have to solve this. So Bhumika has given the answer for previous question. Now let us solve this. I'm waiting for a minute to receive your answers. Kushdeep is asking about question number. No, there is no question number. I'm giving from my side. Random question, mixed questions are there. So first step is open the square. So what will happen? X square, that is a square plus 2ab plus b square, and then divided by x. So we can divide it and see what is available. So x cube plus 2x plus 1 by x. Now for x cube, it will become x power 4 upon 4 plus 2x square upon 2. For 1 by x, it will become log of x and then plus c. So Sankalp, the past one, has given the answer. All right. Then the next one. Integral of root x minus 1 upon root x whole square dx. So here also we are having the whole square. So apply the formula a square minus 2ab plus b square. So now how much will become? Root x square becomes x minus 2 and then plus 1 by x. So integral of x will be x square upon 2 minus 2x plus log of x with base e plus c plus c. All right. Then let's try the next one. integration of 2 to the power of x plus 3 to the power of x upon 5 to the power of x. Now this time what needs to be done? So we can convert this first. We can write them as 2 by 5 to the power of x plus 3 by 5 to the power of x and then dx. So we can apply the formula for a to the power of x. So a to the power of x divided by log of a base e. So we have applied this formula. So 3 by 5 to the power of x divided by log of 3 by 5 with base e and adding the constant c. So Pranav, Bhumika has also given the answer. Then the next one, 10 x to the power of 9 plus 10 to the power of x log of 10 base e divided by x to the power of 10 plus 10 to the power of x dx. So now try the fifth one. Try the fifth one. Till then, Saima is asking about explain third one. See, in third one, what we have done, a minus b whole square. We have simply applied the property of a minus b whole square. So it becomes a square minus 2ab and then plus b square. So this is square, this is 2ab and this one is b square. After that, we have simply applied the formula for integration and got the result. Okay. Now the fifth one. So in fifth one, we can apply the shortcut formula, which we have discussed today in first 5 minutes. That is, if differentiation of denominator is available in numerator, then we can apply the shortcut. So answer will be log of x to the power of 10 plus 10 to the power of x plus c. This will be the answer. All right. Then let's try some more. 1 plus 1 upon x square multiplied by e to the power of x minus 1 upon x dx. Now this is the question. So it looks lengthy, but it is not at all lengthy. This is very easy question. So what we have to do, let x minus 1 upon x is equal to t. Now on differentiating, what we get 1 minus. Now what is the differentiation of 1 upon x? It is minus 1 upon x square is equal to dt by dx. So it is simply 1 plus 1 upon x square dx is equal to dt. Now here we can see that in place of 1 plus 1 by x square and then dx, in this place we can simply write dt. We can simply write dt. So let us write this. So e to the power of t and then dt. Now integration of e to the power of t will be same and adding the constant. In place of t we can write x minus 1 upon x. So this is the final result. All right. Then the next one. Question number 7. Now 4x cube multiplied by e raised to the power of x4. Now this is the question. Now what will be the first step? If we assume let x to the power of 4 is equal to t, then we can see that 4x cube is equal to dt by dx. So 4x cube dx can be written as dt. 4x cube dx can be written as dt. So let's write here e to the power of t dt. Now e to the power of t will remain same and adding the constant. So it becomes e to the power of x4 and then plus c. This is the final result. So Saima is asking to explain 5 and 6 once again. See, in 5, this was simply the shortcut which we have done in the first 5 minutes. So if you have joined the session late, then you can see that portion first, and after that you can try this question. So this is simply a shortcut. If differentiation of denominator is available in numerator, then we can directly write the answer. And in the sixth one, this was substitution method, which we did in previous session. So if you have not attended the previous session, you must attend that. After that, you will be able to solve this question easily. So here what we have taken, x minus 1 upon x, we have taken as t. Then differentiating both sides. After differentiating, we are getting 1 plus 1 by x squared dx is equal to dt. And we have applied this. So we got e to the power of t integration, and this becomes the final answer. All right. Then let's try another one. Integration of dx, x log x, and log of log x log x multiplied by log of log x. This is given. So here also what can be done? Let log of log x is equal to t. If this is equal to t, then we can differentiate it both the sides. So since it is log of x, so derivative of this log, since it is function into a function, we have to apply the chain rule. So for this log, it becomes 1 upon log x. Now, derivative of this log x, derivative of this log x is x. So it becomes x log x is equal to dt by dx. So here again, in place of dx upon x log x, we can write dt. We can write dt. So dt upon, and log of log x was assumed as t. Now integration of 1 by t is simply log of t. And in place of t, what we have assumed was log of log x, and then plus c. So this becomes the final answer. Okay. Log of log of log x, and then plus c. Okay. Then let's try another one. E to the power of 5x square minus 3x plus 2 multiplied by 10x minus 3 dx. So whenever the situation is there, we are having in some raised to the power, and its differentiation is available in the question. Its differentiation is available in the question. Then we can let this value as t. We have taken this as t, so it will become 10x minus 3 dx is equal to dt. So in this place we can write dt. So e to the power of t dt. Now we can integrate this and get the answer. So it will be same e to the power of t plus c, and in place of t we can write again 5x square minus 3x plus 2 and then plus c constant. All right. Then the next one, integration of e to the power of x minus 1 divided by e to the power of x minus x. So now here again clearly we can see that differentiation of denominator is available in numerator, because e to the power of x becomes e to the power of x, that is same, and differentiation of x is 1. So differentiation of denominator is available in numerator. So directly we can write log of e to the power of x minus x, and then adding the constant c. Okay. So in all these places, simply what we have done, we have taken directly the substitution method or applied the shortcut method. So Rohan has given the answer, Sankaldeep has given the answer, Bhumika has given, Divya has given, then the next one, e to the power of x minus, so plus e to the power of minus x divided by e to the power of x minus e to the power of minus x dx. Now this time this is the question. So again, clearly we can see that differentiation of denominator is available in numerator. So we can directly write the answer as log of e to the power of x minus e to the power of minus x plus c. So directly we can write the answer. Okay. Now let's try another one. Now the next one, it is a bit different one. So whenever there is integration of log x all alone, we have to integrate log of x. Now, what is the integration of log x? We know its differentiation is 1 by x and integration of 1 by x is log of x. But what is the integration of log x? So here we know that there is no formula, no particular formula for log of x. So when there is no formula for log of x, one thing can be done. We can apply the formula of UV rule. That is, when two functions are getting multiplied, then we can use it as UV rule. So only one function is given in the question. So we will assume one as another function. So 1 multiplied by log of x. 1 multiplied by log of x. So log is the first function and 1 becomes the second function. Log of x is the first function and 1 becomes second function. Now apply the UV rule. Log of x base c integration of 1 and then dx minus integration d by dx of log x base c integration of 1 dx and then whole dx. So in this way, whenever we assume log as first function, we have to only differentiate log. There is no need to integrate log, and we will always integrate the second function. So log of x remains as it is. Differentiation of integration of 1 is x minus d by dx of log x is 1 upon x, and then integration of 1 is x. So here x will get cancelled. So we are left with x log x base c minus x, and at last at the constant c. So this becomes the final answer. So this is a bit different one. Okay. So whenever log x is there, we have to integrate, take the second function as 1, and then do the integration process. Okay, Priyanka is saying, can you please repeat this again? See, Priyanka, whenever we are having only logarithm, only log is there. So there is no formula for logarithm to integrate. So we have to apply the second function as well. The second function we have taken as 1. Now, 1 is the second function and log is the first function. Now apply the UV rule. Now applying that rule, it becomes log of x integration of 1 dx minus integration of d by dx log x, then multiply by integral of 1. So after solving this, we simply got our result. So most important thing was assume 1 as the second function and then solve it completely. So let's try the similar question. Now this time log of x base e whole square. This is given. So again log is there. So we have to assume the another function as 1. So log is the first function, 1 is the second function. Apply the rule first. So log of x base e whole square, integral of 1 dx minus integral of d by dx log of x base e whole square, integral of 1 dx. Just apply the formula, and this we have discussed in the previous session. So log of x base e whole square, integral of 1 is x minus. Now d by dx of log x square. So it becomes 2 log of x base e, and differential of log x is 1 by x. Then difference is integral of 1 is x. So x and x will get cancelled. So what is left? Here 2 is left. 2 is left. We have kept 2 outside, and we have to integrate again log x and 1. We have to integrate log x and 1 because log x is left here. Now we have did just in the above step, we can write that result as it is. So x log x base e minus of x. So x log x square base e minus 2x log x base e plus 2x and then plus c. Okay. So whenever log is there, we can solve in this manner. Then let's try another one. Integral of x log x plus 1 divided by x and then e to the power of x dx. Now, first of all, what we can do, we can divide the numerator by denominator. That is, we can do this normal splitting. So after splitting, what we are getting is log x plus 1 upon x, and outside the bracket we are having e to the power of x. Okay. So whenever this kind of situation is there, like outside e to the power of x is there, and inside fx plus f dash x is there. So if log x is the function, its derivative is f dash x. So if this is the situation, so we can directly write the answer. And the answer becomes e to the power of x log of x and then plus c. So we can directly write the answer. Then another one. Limit is from 0 to 4, root of 3x plus 4 dx. Now this is the question with limit from 0 to 4. So what can be done? We can treat this, the power as 3x plus 4 Power is half at present and limit is from 0 to 4. So if we integrate, the power will increase by 1. So 3x plus 4 power half plus 1 and denominator half plus 1, and then also this 3x, from this 3x 3 will also be written in the denominator. So let's simplify and see what is the result. And one more thing, constant we will not write because it is definite integral. So we will write from 0 to 4. From 0 to 4. So let's solve this. 3 multiplied by 4 plus 4 to the power of 3 by 2 upon, we are having 3 multiplied by 3 by 2. Minus, we can apply 0. So 3 into 0 plus 4 to the power of 3 by 2 upon 3 into 3 by 2. Now we can solve and get the result. So what is 3 into 4? 12. 12 plus 4, 16. So 16 can be written as 2 to the power of 4 multiplied by power 3 by 2. And 3 in denominator we are having 9 by 2. It can be written as 2 by 9. Minus 2 by 9. 4 can be written as 2 square multiplied by 3 by 2. So here let's do the cancellation and get the result. 2 by 9 is common. So 2 to the power of 6 minus 2 to the power of 3. So what is 2 to the power of 6? 64 minus 8. How much? 56. So 112 upon 9 becomes the final answer. One one two upon 9. All right. So this was question number 15. So now the next one, integral of 2x upon 1 plus x square dx from 1 to 2. 1 to 2. Now how to do this question? So we can clearly see that differentiation of denominator is available in numerator. So differentiation of 1 is 0 and for x square it is 2x. So this 2x is available in numerator. So that is why we can directly write the result as log of 1 plus x square, limit is from 1 to 2. So log of 1 plus 2 square minus log of 1 plus 1 square. So we are getting log 5 minus log 2. So log of 5 by 2. Okay. Then one more variety, 0 to 2 x plus 2 divided by x plus 1. X plus 2 divided by x plus 1 and then dx. Now, the power in both the numerator and denominator is same. Both are having power as 1. So if power is same, then also we can divide them, or if we want, we can split them directly also. How to split them? This 2 can be written as 1 plus 1. 1 plus 1. So we can write this as x plus 1 plus 1 divided by x plus 1, and here also x plus 1 and then dx. So it becomes integration of dx plus 1 upon x plus 1. So how much it will become? X plus 1 upon x. Now 1 upon x can be written as log of x plus 1. Now apply the limit. Since the limit is from 0 to 2, we can write 0 to 2. First apply the 2. So 2 plus log 3 minus 0 plus log of 1. Now log 1 is also 0. So what is the final answer? 2 plus log 3. 2 plus log 3. Okay. So many different varieties are, I think, covered now and revised now. Then one more. (18) 1 to e square dx upon x 1 plus log of x base e and then whole square. And then whole square. Now this is the question. How to solve this? So first step is use substitution method. So let 1 plus log x is equal to t. So 1 upon x dx is equal to dt. 1 upon x dx is equal to dt. So in place of dx upon x, we can write dt. And in place of 1 plus log x, we can write t. We can write t. So it becomes dt upon t square. Now what is the integration? T to the power of minus 2 plus 1 upon again minus 2 plus 1. So it becomes minus and t to the power of minus 1. Or it can also be written as minus 1 upon t. In place of t, we can write again 1 plus log of x. 1 plus log x. Now what is the limit? The limit is from 1 to e square. From 1 to e square. So let's apply the formula. Minus is outside. 1 divided by 1 plus log e square base e minus 1 upon 1 plus log 1. Now log e base e is there. 2 will jump forward. So 1 upon 1 plus 2. And log e base e is always equal to 1. So we are getting 1 by 3 minus 1. Final result is 2 upon 3. Final result is 2 upon 3. So Rohan is saying minus 1 by 6. No. Bhumika is saying 2 by 3. Yes, 2 by 3 is the correct answer. Okay. Then next, let's try the different question. Now this time the question is, limit is from 0 to 5, modulus of x minus 2 dx. Now this time, this is modulus. So modulus means which always gives positive result. Which always give positive result. So if we insert, let's say negative 5, it gives 5. If we insert positive 5, then also it gives 5. That means the original function can be positive or it can be negative. The original function can be positive or negative. So we can split this into two parts. So one is positive and one is negative. So what we can do, in place of modulus, we are applying the normal bracket. Okay, writing it one more time, x minus 2 dx. Now let's take one value negative, another value positive. Limit will be same, that is from 0 to 5. So why we have taken two different values? Because whenever modulus is there, there are two possibilities. Value can be negative or it can be positive. So that is why we have taken both the options, one negative and other positive. Now we can solve and get the result. For the first portion, x becomes x squared by 2, then 2x. Limit is from 0 to 5. Plus, again, x squared by 2 minus 2x from 0 to 5. So let us apply the formula. Okay, one more thing here we can do. We can split this. We have to change the limit here. What we can do here, since the value of the function is x minus 2, we can equate this with 0. We can equate this with 0. Then what is the value of x? X is 2. The value of x is 2. Now, if the function x minus 2 is there, and if we put any value below 2, if we substitute any value below 2, the result will be negative. So if we are substituting, let's say 1, the result is negative. If we are substituting 1.5, then also the result is negative. So if we put value less than 2, it will be negative. And if we put more than 2, like 3, then it is positive. If we put 4, then positive. 5, then positive. That means the negative value can have the limit only from 0 to 2. So between this 0 and 2, the result will be negative. And from 2 to 5, the result will be positive. So here, what we can do, we can change the limit. That is from 0 to 2 and then from 2 to 5. Okay, so this we have to do. We have to split the function into two parts. One part will be negative, other part will be positive. So For negative, we have to find out the limit up to which place the function will be negative, and after that the function will become positive. So that is why we have split it into two parts. All right. Now just apply the limit. So it will be 2 square by 2 minus 2 into 2. Applying 0, it will give 0. Then 5 to the power of 2 minus 2 into 5, and then minus, this time with 2. 2 to the power of 2 upon 2 minus 2 into 2. So let's solve and get the result. This is 2 minus 4, then 25 by 2 minus 10, and then minus 4 by 2 is 2, and then plus 4. Now we can do just the simplification and get the result. So the final answer which we are getting is 13 upon 2, and Bhumika has given the answer. Yes. Right. So 13 by 2 will be the correct answer. Pushdeep Kaur has also given 13 by 2. Rohan is asking 1 plus log 1 will be 2. No, log 1 is 0. So 1 plus 0 becomes 1 only. Now the question number 20. Let's have a similar question so that you can easily split. Mod of x minus 5 dx, limit is from 2 to 7. So this time we can again see that x minus 5 is equal to 0. So x is equal to 5. So if we put any value less than 5, it will be negative. Then if we put value more than 5, then it is positive. Less than 5 negative, more than 5 positive. So we can try here. From 2 to 5, it will be negative x minus 5. And then from 5 to 7, it will be positive. It will become positive. Now we can solve and apply the limit, get the result. Okay. Then the next one. Now let's take one more question. Now this time the question says the equation is there ax square plus by square is equal to 5, and this passes through 1 comma 1, and the slope is equal to 3 by 2. The slope is equal to 3 by 2. We have to find value of a and value of b. So this two we have to calculate a and b. So first step is what we can do, since slope is given, that means dy by dx is given, so we can differentiate first. So differentiating with respect to x. So let's differentiate. Ax square will become 2ax plus by square. It will become 2by and then dy by dx. And now this is equal to 0 because differentiation of 5 is equal to 0. Now what needs to be done? Here 2 can be taken as common. So we are left by dy by dx is equal to minus ax. So dy by dx will be minus a by b and then x upon y. Now since it is passing through 1 comma 1, so the point is x coordinate is 1 and y coordinate is also 1. So we will simply get dy by dx is equal to minus a upon b. Minus a upon b. And since the slope is also equal to 3 by 2, that means minus a by b is equal to 3 by 2. This will give us minus 2a is equal to 3b. Or we can say that 2a plus 3b is equal to 0. This becomes the complete equation. This becomes the complete equation. So we can name it as 1. Now, secondly, since the equation is passing, the given equation is passing through point 1 comma 1. So this 1 comma 1 will satisfy the equation. So we can substitute the value of 1 comma 1 in the given equation. So a into 1 square plus b into 1 square is equal to 5. So a plus b is equal to 5. This is equation number 2. Equation number 2. Now we can solve both the equations and get the result. So let a is equal to 5 minus b and substitute in the first one. So 2 into 5 minus b plus 3b equal to 0. So what is the final result? B is equal to minus 10. Now we have to calculate the value of a. We can substitute in the equation. A minus 10 is equal to 5. So a becomes 15. So this is the value of a and b. So in this manner, we can easily calculate and get the result. All right. So in this question, there was given equation passing through a point and slope was given. So first of all, what we did, differentiate and then got the value of dy by dx. In place of dy by dx, we have put 3 by 3 and got the equation. Now, in order to get the second equation, we have inserted the point in the given equation and got second one. Now, after solving both of them, we have got value of a and b. So in this manner, we can easily calculate the result. So now we have covered all the varieties, all the different formulas of the chapter integration. Now you can practice for more questions and so that you will be able to solve them easily in examination. So integral and differentiation, both of these chapters jointly come around 3 to 5 marks. No fixed rule is given like how many marks of question will be coming from this chapter directly, but on an average, this is the weightage. So it can be varied anytime, but yes, on an average, it is 3 to 5 marks. All right. So here we completed the topic integration, and don't forget to revise the today's session today only so that you can remember all the formulas and concept for the longer period of time. All right. So let's meet in the next session for the new chapter. Till then, bye everyone. Take care and see you soon.